diagram shows the circle with equation x square plus y square minus 14x plus 8y plus 36 equals to 0. And the line y equals to minus 2. The line intersects the circle at points A and B. Center C, it intersects. Okay, yeah. So this is the equation of the circle, and the line y is equals to minus 2 is this, and this line intersects the circle at points A and B. The center of the circle is C. Find the coordinates of A, B, and C. A, B, and C. So the first thing that you should be finding would be the center of the circle by rearranging this equation of circle, okay, and making it into the standard form. So first write that up, x square minus 4, I'm rearranging from the start, so minus 14x plus y square plus 8y plus 36 equals 0. So what do? We complete the square for both x and y equations. So if this is 14, so the half of it is 7. So we'll be adding and subtracting 7 square. 7 square adding and subtracting 7 square. Then we have, now y square is y square plus 8y. So what is the half of 8? 4. So we'll be adding and subtracting 4 square and subtracting also 4 square. Okay, now make the brackets to show the complete square. So this is x minus 7 whole square plus y plus 4 whole square, and then plus 36 minus 49 minus 16 equals 0. So adding this up will give you minus 49 minus 16 will be minus of 65, and plus 36 will give you minus of 29. Okay, to make it into the standard form, we can take this to the other side, 29. And the last thing that we should be doing is we will be, as we know that x minus a square plus y minus b square is equals to r square. So let's represent this in the form of r square. So how it will look like? It will look like this, root 29 square. Okay, so from here we can clearly infer two things. One, the center of the circle, and the second is the radius. So the center would be 7 comma minus 4. Putting this equals to 0 gives you a x coordinate of center, and putting this equals to 0 gives you y coordinate of the center. So this is 7 minus 4. Let's represent this also on your 7 comma minus 4. And the radius is supposed to be root 29. Now, the second thing is we need to find the coordinates of B and C, A and B as well. So what do we know about that? We know that this equation is y equals to minus 2. So that means the y coordinate of point A is also minus 2, and y coordinate of point B is also minus 2. Okay, so if we substitute y equals to minus 2 in this given equation, you can take either form of it, actual form or this completed square form of circle equation, and put minus 2 in this. So as A and B are the points of intersection, so you will be getting your x coordinates for the point A and B. Okay, so I'm substituting y equals to minus 2 in the original one, x square plus y square minus 14x plus 8y plus 36 equals 0. So yeah, do that. Now look into this. It will give you x square plus minus 2 square minus 14x plus 8 times minus 2 plus 36 equals 0. So this gives you x square plus 4 minus 14x plus, no, not plus, minus 16 plus 36 equals 0. And simplifying this will give you 36 plus 4 is 40 and 40 minus 16 is 24. Again, we need to break the middle term to get the 2x values. So we need, upon multiplication, we should be getting 24, and upon adding or subtracting, we should be getting 14. So 8, no, we will be getting, if we subtract 12x minus 2x, so this gives you, sorry, add up 12 and 2, it will give you 14, and upon multiplication, it gives you positive 24. Okay. So this is how you get the factors. X minus 12 minus 2 common is again x minus 12. Taking x minus 12 common, we are left with x minus 2. So this implies either x minus 12 is equals to 0 or x minus 2 equals 0. So this gives you x equals to 12 or x equals to 2. So now represent these points. So obviously point A will be having coordinate 2, and this will be, B will be having 12. Okay, so this is how we got the coordinates of points A and B and C as well. Okay, now let's move on to part B. Part B says find the angle ACB in radians. ACB. Instead of just going back to the diagram again and again, I'm copying this diagram and putting it here again. Okay, which angle do they need? ACB. So this means it's better if you take some brighter. ACB. So ACB. Okay, this is your angle that you need in radians. How do you find this angle? ACB. Okay, to find this out, first I'm just removing this. This is making it a little confusing. So if I am able to remove this, it would be better. Okay, so the thing is better that we need to find this ACB. And if you could see that, you can see this triangle ABC. So you can use, as you know, that this is root 29 and this side is also root 29. So you know two sides and you need to find the included angle. And also you can find out this AB length also because you know the coordinates of AB. So if you find AB length, you can use law of cosines to find out angle ACB. So using law of cosines, that says A square. Okay, if we call this opposite side to be C, opposite of B to be B, opposite of A to be A. So I am representing it in the same format. If we want to find the angle C, so let's keep this way. C square will be equals to A square plus B square minus 2AB cos of C. So when we need to find just cos of C, so we will be shifting everything, rearranging it. It will become A square plus B square minus C square. First I'm shifting this to the other side and then divided by 2AB. Okay, now substituting in the values, but before that we need to find first AB. So AB would be found by using the distance formula, and the distance formula is x2 minus x1 square plus y2 minus y1 square. So first write the coordinates, as always I do. Write the coordinates so that there is no confusion. Right above or on the side, and B is 12 comma minus 2. So x2 minus x1 would be 2 minus 12 square plus y2 minus y1 would be minus 2 minus of minus 2 square. So this will give you 10 square. This will give you 0 square, so just ignore that. So 10 square under the root. And if it is 10 square under the root, so we don't need to expand this. Instead, just cancel out square with the square root and we are left with AB to be equals to 10. So now C is equals to 10. And now let's substitute in the values. We will be getting cos C equals A that is root 29 square. B is also root 29 because both are radii of the same circle. Minus C square means minus 10 square over 2 times root 29 times root 29. Solving this all will give you 29 plus 29 minus 100 over 2 times 29. So 29 plus 29 is 58 minus 100. Over 2 times 29 is again 58. So this will give you 42 over 58. And then, okay, one more thing is this. Minus 42. So this will give you minus 21 over 29. And now angle C or angle ACB is equals to cos inverse of this. So when you do this cos inverse in radians, we need to find So keep your calculator in the radian mode and find the angle that comes out to be 2.3805. Okay, so this is your angle ACB in radians. Okay, this is one way of doing it by using law of cosines. Another way could be if instead you use these two triangles, okay, and use your trigonometric ratios or use base times height, because see, this is -4, so your height would be 2, and base you can find out by again the distance formula, so that is 10. So yeah, so what do we need to find? Angle. Half AB sine C, no, not really, not the area formula, sorry. You should be using this area of one triangle and the area of the other triangle by using your, what you can use is, you can use find this half angle by taking this side, that is 2, and this is 29. So if you use cos C, cos of C will be equals to, yeah, you can use this 10 side as well, you can use this height as well. So cos C will be equals to, not cos C, but this much. Let's call it to be theta. So cos of theta will be equals to adjacent 2 over hypotenuse, that is root 29. So you can solve it to find this theta and then multiply it by 2 to get your required angle. But I guess law of cosines is a better way of doing it. It makes it more simpler and easier. Okay, so that's all about part B. Now we also have part C to this question, so let's get into that. Okay, so the part C says this chord AB divides the circle, the chord AB, they are referring to this chord, this one. This chord AB divides the circle into two segments, this segment and this segment. Find the area of the larger segment. So what do we need to find is the area of this larger segment. So for this reason, I'm just taking this diagram again. So the area of the larger segment is that what we need. So this is your AB part, and we need the area of this larger segment. Okay, this part. So how can you find it out? If you can clearly see, there are two parts to it. One is your triangle and the other is your sector. Okay, so you can, the area would be, so area of the larger segment would be area of the segment would be equals to area of triangle ACB plus area of sector ACB. Okay, so we will be using this equation for this question. Like, this is what we get from the diagram. So now find it out. Area of triangle is, you can find area of triangle as I told you by using base times height. Okay, simply by using that. Base times height is what would be 10 times 220. So area of your triangle you can find by any method. You can use the law of sines. So the area would be either equals, area of triangle would be either equals, you can use half AB sine C, means half of root 29 times root 29 over sine of C, and your angle C you just found in radians to be 2.3805. Either you use that, or you can use half base times height, and your base is 10, and your height, I just told you that from here -2 to -4, because this center is at -4, so this is 2, height is 2. So you can use that to get your area to be 10. In both ways, you will get the area of triangle to be 10. Now, your area of the sector, you know, for the area of the sector, the formula is half r square theta. Okay, and r is, you know, to be root 29, and theta is, you just find, theta would be different. This is your chord, sorry, sector. So your theta is 360 minus, or 2 pi minus angle C. Okay, so 2 pi minus C would be two pi minus 2.3805 would be 3.9026. 3.9026 in radians. So theta would be, you will be writing 3.9026 half r square theta. So it would be like this. So when you multiply this with 29 and divide it by 2, you will get 56.5889. So now adding up these two areas, because you need the area of the whole sector. So it turns out to be, now I am substituting the values above. It would be area of the triangle is 10 plus area of the sector is 56.5889. So it turns out to be 66.588. Okay, so yeah, this is all about your question number 8. Okay, we found the center and the coordinates A and B of A and B point. Then in the part B, we found the angle C by using law of cosines. And lastly, in part C, we have found the area of the bigger segment, the larger segment, by finding the area of triangle and area of sector that comprise that segment. That's all about your question number 8.